Okay, hi, this is our team interview for Module 2. I'm Heather Arcos. And
I'm Amy Benzie.
We have Deanna Medlock, John Tinney, and Kristen Hibbs.
John Tinney right here. Christian. All right, we're going to start with the questions to Miss Heather. What are the sources of sugar added to our diets?
Okay, on my pie chart, it shows just the different sources from the percentages, like the breads. It shows there's 2% of sugar added to our bread. Our tea has a 5% sugar added. Sugars and honey, 5%. And then the most one is the soda, the energy drinks, and the sports drinks. That says 36% that they add sugar to that, and that's in our diet. That just seems like an extreme amount. I think we just kind of need to watch our sugars.
I agree.
All right, Deanna, what is an asymptote?
An asymptote is a place on the graph where the data would be undefined, meaning it would never reach zero. It would never cross the axis. This is called a horizontal asymptote on the x-axis, meaning that a straight line is the limiting value of a curve, can be considered as tangent at infinity. The asymptote of the curve is the straight line traced by a point traveling in a constant direction, a line of zero curvature, which is the shortest distance between 2 points is a straight line. And this is where we're showing how our curve is measured, coming down to where it never reaches zero.
Christian, what does the E in the exponential trend line equation mean?
Well, the E is a famous irrational number in mathematics. It was made by a guy named Euler, but it's spelled Euler. The number starts with 2.718, and that is just an important number in math. And we also use that number in our equation to find the trend line for the medication half-life. Okay, for John Tinney, do the half-lives of medications affect our lives?
It certainly affects mine. I have to take blood pressure medication morning and night, and you'll see here on the half-life of metoprolol, that's the medicine I take every day. It breaks down to, I take 100 milligrams in the morning, 100 milligrams at night, and at 3.5 hours, I've still got about half a dose in me. Between 7 and 10.5 hours, I have, or 10.5 and 14 hours, which I take it every 12 hours. So I still have between 6.5 milligrams and 12.5 milligrams in my system. So I have to take another pill where I have, my blood pressure constantly taken care of. I call it my anti-explosion medicine because I don't want to blow up. Ms. Benzie asked me to talk about marijuana whenever I was doing this. And if you look at the half-lives of marijuana, it stays in your system for a really, really long time. And for what I do for a living, I'm a police man, and I do BWI enforcement and everything else. We have these folks that are driving, and they've used marijuana, used alcohol, used all that type of stuff. And it doesn't matter to us on a nanogram value on marijuana. It's in their system or it isn't in their system. And if you look at the chart, the way it works here, it stays in your system for over 300 hours. You'll still have a trace amount that they can check. And the way it would affect your life there is if you was trying to get employed, the employer would, have you go take a urine test, and if what we call it, if you pissed hot, then you don't get the job. That's just the way we call it all the time on ours. And so you gotta be careful, and you gotta think about it if you're going to be using these type of substances. For Heather, is it beneficial to know how to calculate the half-life of medications?
Yeah, it is. Just what you were just saying too. Knowing how to calculate it can be very beneficial. It'll just tell you how long the medication stays in your body, when it's time to take more medication, or when it's time to just wait. It'll let us know when it's safe, especially like if you're giving medication. Like I give medication to my daughter. She takes albuterol for her asthma. I found this one really interesting. I got to know how long the medication stayed in her system. Like when she first takes it, it shows at 6 hours she still has about half, so that's pretty good. I know, like, she runs cross country and track, so she takes it before she should be good by the time way after the race is over, and she'll be fine. Thank you for asking that one.
Yeah, that's a good one. Thank you.
Okay, Christian, how many times can a number be divided?
I did this question because, you know, a lot of people are talking about the half-lives of medication, and that's very useful. So then you can see when to take medication and when not to, because you don't want to take too much if you still have some medication in your system. So I just went with how many times can a number be divided, because that's what we did with these half-lives. And what we found out is a number can be divided infinitely. What it happens is it just keeps going down to a fraction of a fraction of a fraction, but it will never be zero. So a number can be divided an infinite amount of times.
Okay, Christian, what do you think is the difference between correlation and causation?
Okay, well, as we've talked about previously, correlation and causation are not the same thing, but they are often accused of being the same thing. So in my graph right here, we see the GMO crops versus deaths. We see that in the later years, 2007 and up, the more GMOs we use, the more deaths there are. This is a correlation, so that just means it is a related variable, but that does not mean it is the exact cause of the deaths.
And I would like to point out that the graph here for the deaths is not, you know, right, but everything you said is correct.
Okay, so this is for Tinney. Can we assume that the foods that we eat have no effect on our health?
We've been kind of talking about this with the correlation and causation. And with this question, can we assume the foods that we eat have no effect on our health? I think not. And the old saying goes, you know, we are what we eat, or you are what you eat, has never been truer than about the things that we eat. You know, the genetically modified foods that are out there these days, I mean, everything from chicken to hot dogs to corn, everything else has all these different things that they add to them. And one thing about these, the genetically modified corn, they use this glyphosate, which is basically Roundup. We all use Roundup. I use Roundup at my house. I probably shouldn't, but I use it to keep the weeds out of the fence line. And this just shows how that autism has increased by the usage of the glyphosate on corns and soy and everything else, because back in the 90s, they didn't use very much of it. As the years have gone on, they use a lot more of it to regulate the weed control and all these other things, and they want to have more crops and all this type of thing. Well, there's a direct correlation with the usage of Roundup or glyphosate and autism. If you can look at this graph, back in the 90s, we didn't have hardly any. We had about, got it written down here somewhere, 25,000 cases, I think it was, and there was only, you know, just a little bit of the glyphosate applied. By the time we get to 2009, 2010, as Miss Benzie said a little bit ago, that's probably a year or two behind. We have 375,000 cases of autism, you know, about what they've used on all the crops that we have. So I think that all these weed killers and things like this that they apply to crops certainly has a effect on our health.
And the propensity of using Roundup makes it very simple to solve our problems, but propensity can actually cause a lot more problems, or at least correlate to them. Right, Tinney?
Exactly, and that's just like a copious amount of glyphosate being used, so you got to be careful of that stuff.
Very good. Thank you, Tinney.
All right, this is for Mr. Christian. What is the trend in this graph, and how do we find those values in yellow?
Okay, so the trend in this graph, this is basically saying that your reaction time is slowed down depending on your blood alcohol level. And the main question is, how do we find those values in yellow? Well, we've been doing this all semester. We have the median, the mean, the standard deviation, and the coefficient of variation. The median, as you know, is just the number in the middle when you line them up in order. The mean is the average number between all of them, so you add them and then divide by how many there are. The standard deviation is a little more complex. It's how far the data should be spread, and we find the mean and subtract the square root. And the coefficient of variation is the most complex, and it is basically a variation of the standard deviation. And to find that, we take the standard deviation and divide the mean.
Very good. Thank you, Hibbs. Very nice, Hibbs. Go on.
Christian, you got a
Okay,
question?
so this is Medlock. How do we become impaired, and how does it affect our reaction time?
With what I am going to school for, this is something that I very well have to know, and I'm going to enlighten y'all on this. So the amount of alcohol a body can process depends on the type of drink, a person's weight, and the serving size of the drink being consumed. So one drink is considered to be a 12-ounce beer, a 5-ounce glass of wine, or 1.5 fluid-ounce shot of liquor. The general rule of thumb is it takes about 3 drinks an hour for a woman to reach a 0.0 blood alcohol consumption, and it takes about 4 drinks an hour for men, but those are general guidelines that's just based upon the weight of an average person drinking. So an average person who weighs about 100 pounds, it would take 3 drinks an hour to reach the 0.8 blood alcohol consumption, but that goes up by weight too. When we created this chart, the distribution created a nice bell-shaped curve, which you see how it is normally distributed, which means that we didn't have anyone who had an outrageously low reaction time or an outrageously high reaction time. Thus, the reaction times had a normal distribution. The mean reaction time for someone who had a 0.08 blood alcohol consumption level was 2.4 seconds. But you got to consider too that in comparison to, for example, how long it would take you to pick up your phone. So it doesn't really translate to us exactly what task was seemingly being reported that they were doing.
Very interesting. Thank you, Medlock.
Tinney, is impaired driving a problem in Garland County?
You bet it is. This Venn diagram kind of goes in and starts talking about polydrugging, which is, when someone uses, say they drink a beer and on top of their medication, they're already taking Xanax or something like that. They're a little stressed out and everything else, and so they take a Klonopin or they take a Xanax or anything like that, and then they have a beer on top of that. Well, and then they try to drive. I tell people all the time, I don't care how much you drink, I don't care how much drugs you use. You can drink a battleship full of whiskey. Doesn't make any difference to me as long as you don't drive. I'm in the business of arresting people for driving, and this graph is spot on for the way things are with cannabis and alcohol and all the different other medications, the narcotic analgesics and everything else that people take. In Hot Springs, we're pretty lucky because we have a really, really, really good conviction ratio. I think we have about a 93% conviction ratio, 93 to 95, and it's that's unheard of, because when we arrest someone, we have a good case, we write up good reports and everything else. In our cases, I'm a drug recognition expert, and this Venn diagram that I'm looking at here is really interesting to me because it shows the overlapping things that I talk about, the overlapping effect and the negative, what am I trying to say, the additive effects of different drugs. Alcohol is a CNS suppressant, Xanax is CNS suppressant. So if they use 2 CNS suppressants and then put a little bit of weed in there, and we really get an impaired person. They fall asleep, they stay at signal lights, they don't move, they do all kinds of goofy things that we see people in Garland County. So yes, it is certainly a problem in Garland County. Christian, how do we calculate the standard deviation?
So in my last question, I was talking about the mean, median, and all that. Generally speaking, this is it more broken down, but mainly the coefficient of variation. So in the middle of this graph, you see the U-shaped letter. That is where our mean is. Everything to the right of it and the left of it is our standard deviation.
Hold on, let's go again. Now what happened?
Is the connection okay?
Oh, it's back.
Okay, but so the standard deviation on this graph, to calculate that, we worked out the mean, we subtract the squared of the result, and then we found the mean of that and squared it. Once we had the coefficient, we just plugged it into Excel and we changed the simple numbers to get the variations. Okay, Medlock, what does the tightness of the trend lines tell us for each age group?
Okay, the standard deviation, the coefficient of variation, and the distributions of the dots around the trend line are in relation. This information tells us where the points need to be. Standard deviation is a measure of spread, so it tells us how wide or concentrated our data is. Our coefficient of variation tells us how data points are dispersed around the mean, and that tells us how tight the trend line is versus to how dispersed it could be.
Very good. Thank you.
Tinney, how bad is the problem of distracted driving?
The problem of distracted driving that I see in Garland County is terrible. Everybody's on their phone nowadays, old, young, it doesn't make any difference. And they're driving along, they've got it in their hand, and we have a statute, 2751, I think it's 1504, it's called Paul's Law. And it's for a young man that got killed because he was texting and driving. And this young man, that shows that the standard deviation of the 16 to 24-year-old group was the highest. These two graphs here show that, and it shows the trend line, how that it has increased over the years. Nowadays, like I said, we don't do anything. I can remember back in the day, I remembered phone numbers for everybody. Now I've got a cell phone, and I don't remember anybody's phone number. I said, hang on a second, I'll get it for you. But the cell phone usage whenever they're driving is just like someone that's impaired with alcohol. They drive, what we call the mustard and the mayonnaise, the yellow line and the fog line, the white line. They drive all over the road. They drive slow. They don't pay attention. And it's, I've stopped a lot of them, and I write the tickets for, it's about a $300 ticket in Garland County nowadays. So you don't need to be texting and driving.
Wow,
And
yeah.
it is a real problem.
Save lives, Tinney.
That's right.
Yeah.
Thank you, Tinney. Arcos, how is the wealth of the U.S. distributed?
Well, as you can see on the graph, it shows that like the 1% own most of the wealth in the United States. That's 1% of the population. Then it shows the biggest percent of people, it says 40% of the population, they own less than 0.9% of our income. That just means that, very few people in our country are the wealthiest. They have almost all the money. And then most of us are have the smallest amount of the U.S. wealth. It just doesn't seem like it's distributed very well.
It does feel like there are some ways that we could improve. It's difficult.
Yeah.
Very good. Thank you, Arcos.
All right. Christian, what is the irony of our wealth distribution?
Well, the irony in our wealth distribution is the ratio of our wealth distribution. The ratio is very skewed. You can see that a very small percentage of the population has a majority of the wealth, whereas a majority of the population does not have a lot of the wealth. I'm no economics major, but I did learn the French Revolution, and from what I'm seeing with this is something's got to balance out, because inflation and just it'll be top heavy basically. So you can see that a majority of our population, 40%, 20%, and then another 20% combined make up about 14% of all the wealth in our country, which is a very small fraction. Okay, Medlock, how do we measure skewedness?
Okay, I found this one more interesting when I went back and re-looked at it. So bear with me because I pretty well broke this down, and I found it very, very interesting to fully understand how to read these types of graphs and to understand the data that you're looking at. So it's one thing to look at two sets of data and determine that one is symmetric while the other is asymmetric. And then it's another to look at two sets of asymmetric data and say that one is more skewed than the other. So it's very subjective to determine which is more skewed by simply looking at the graph of the distribution. So this is why there are ways to numerically calculate the measure of skewness. So one measure of skewness, called Pearson's first coefficient of skewness, is to subtract the mean from the mode and then divide the difference by the standard deviation of the data. And the reason for dividing the differences is so that we have dimensionless quantity. And this explains why data skewed to the right has positive skewness, and so subtracting the mode from the mean gives a positive number. A similar argument explains why data skewed to the left has the negative skewness. So Pearson's second coefficient of skewness is also used to measure the asymmetry of a data set. For this quantity, we subtract the mode from the median and then multiply this number by 3 and then divide by the standard deviation. So skewed data arises quite naturally in various situations. Incomes are skewed to the right because even just a few individuals who earns millions of dollars can greatly affect the mean, and there are no negative incomes. So data that's skewed to the right, which we see over here as our long tail, extends to the right. In an alternate way of talking about the data set skewed to the right is to say that it is positively skewed. In this situation, the mean and the median are both greater than the mode. And then as a general rule, most of the time for data skewed to the right, the mean will be greater than the median. So in summary, for a data set skewed to the right, that is that you always have a mean greater than the mode. You will always have a median greater than the mode. And then most of the time, the mean is greater than the median. And so if the data is skewed to the left, then the situation reverses itself.
Wow, very good. You stretched that scenario beyond the scope of this class. I'm impressed. Thank you, Medlock.
Tinney, what happens with our tax dollars?
Our tax dollars, well, the pie charts that come up here, they outline the percentages of where the government uses our tax dollars, both nationally and in our state. I'll tell you about it. Nationally, our tax dollars are mainly spent on healthcare, Social Security, and defense. If you can look at the charts there, and it shows the different things of where our federal tax dollars are spent. Our tax dollars are spent mainly on healthcare. The big blue is mainly healthcare for, especially the state of Arkansas. We have so many people that are on welfare and Medicaid and that type of thing. Arkansas spends about 20% on education, and then the rest of it is spent on pensions, or a lot of it's spent on pensions. It's kind of interesting to us. Miss Benji and us were talking about how much the government, the federal government, spends on education. It's only about 2%, whereas our state spends about 20% of its our tax dollars on education in Arkansas. I guess with the lottery and everything else, it works is the way that goes up. But these two graphs here kind of show that, and there's legends that break down the percentages for each one.
Very good. And just real quick, I was thinking when Medlock was talking, she said no negative values for income, but really if we thought about all of the, substance, or not substance, but, the substitution money that is given in to the welfare system, that might be able to be counted as negative,
Yeah, could be. And that graph is kind of, it's kind of deceiving because it looks like the people with the most money would be the highest, but actually the people with the most money were the littlest,
Yeah.
It's kind of deceiving when you first look at it. Ms. Heather, where are Arkansas state tax dollars spent on?
Okay, well, they're spent a number of ways, just like our federal taxes are. The majority of it seems to be spent on Medicaid at 25%, or this other column, which on the site that I used, it didn't explain what other was. That just kind of makes me wonder where that's going. And then on our education, the site that I looked up says 15, and I know, Tinney, you said it said 20 on yours. It just different information, I guess. I guess that is higher than the federal, that it only spends about 2%. And then on here it says that 15% of our higher education, that's where our tax dollars go to. So at least it seems to be more than what our federal government uses it for.
Hey, Medlock, how do I get back the most on my return?
Income tax bracket. So, as your incomes go up, portions of your income are subject to different tax brackets that progressively increase the percentage of the tax you pay on that income. So if you're single, and this was going by 2018 that we just filed, so it's up to date. For instance, you'd pay 10% on your income up to $9,525, then 15% on income between that and up to $38,700. So choosing a different status may change the point at which you move between the brackets. A married couple filing jointly in 2018 stays at 10% until their joint income reaches $19,050, while for head of household, the cutoff is $13,600. So getting the highest refund possible is generally top priority on nearly everyone's taxpayers list, although various factors such as your filing status, number of allowances you claim, and which tax credits you qualify can impact your refund, which includes earned income tax credit, additional child tax credit, and whatever portion of the refund beyond that needed to bring your tax obligation to zero is refundable to you. But you have to also consider that while receiving a large refund is great at tax time, keep in mind that it's not free money. They're just simply returning your own money back to you, and that larger refunds often mean you've likely been overpaying on your tax refunds. And I found something very interesting that I want to throw into us. A deduction for student loan interest. As long as your income is not too high to qualify for the deduction, you can deduct up to $2,500 in interest paid on student loans, even if you don't itemize. But you must be legally obligated to pay the loan, and you must have incurred the loan in pursuit of an eligible degree or certification. So that might be something to look into if you guys are paying out of pocket.
Medlock, remember that for your Module 3 Excel report when you guys do your student loan graphs. You can add that in there. Very good. Thank you.
All right, Tinney, does getting a raise always result in more take-home pay?
No, ma'am, it doesn't. As you can see from the graph and the data here, that it depends on how you file. If you file head of household and you got a $2,000 raise, it looks like you're going to spend about $8,000 more in taxes.
Wow.
If you file single with that same raise, you'll get to keep about $1,500 more than filing the head of the household. If you're married, filing jointly is the best result because you'll get to keep about $10,000 more than filing head of household. The ratio in filing head of household versus single is about 10% of the old pay. It's married filing jointly is the best rate for old and new pay, but the initial deduction is the same for both. The ratio for the increases are not as great as you would think, but it's pretty broad for all levels of income. One of the questions we asked is, what would you change if you were in charge of taxes? I would try to implement a flat tax rate where everybody would pay, and I do a lot more sales tax, type things than we do now. I mean, Arkansas sales tax in Hot Springs is already about 10%, but I would like it where everybody that comes to Hot Springs, anytime they buy anything, would be, they pay the sales tax on it. On vehicles, is what irritates me more. We have to pay property tax on stuff that we already paid tax on, that we already own. If we buy a car and it's over, I think, $3,000, $4,000, you got to pay tax on it again, but taxes are already paid on it and it was bought new. Mm-hmm. So they're double dipping all the time, and it's just kind of a racket, I feel like, but it's the nature of the beast. All right, Miss Heather, what percentages of Americans avoid fat in their diets?
Okay.
I don't.
All right. On my chart, it shows the different age groups. We have the 65 and up, 50 to 64, 30 to 49, and 18 to 29. The highest percentage seems to be on the 65 and up. That maybe just as we get older, our bodies change, and we just have to take better care of ourselves.
We know more stuff.
Sorry?
And we know more stuff.
That is true, yes. And then from 50 to 64, it's a little bit lower at 53%, 30 to 49, 49%, and then 18 to 29, 41%. That doesn't seem like a lot, probably because, you know, when you're younger, you probably have a better metabolism. You don't think of the future as much. Like, you just, oh, there's no consequences. I guess we all probably need to start here and probably have this percentage where as the younger we are, the more we try to avoid it. That way, as we get older, we don't have those same health problems.
Right.
We already know how to, you know, control our diets.
Very good. Thank you.
Okay, and that is the end of our slideshow.
All right. Very good. Thank you each for participating.
Cool.
Fantastic work, you guys.